Welcome to the Heitkamp Planetarium's 2020 Homecoming Show. My name is Tyler Frost, and I will be one of your presenters today. Accompanying me are Jeff Heitzman and Zach Couture. Our program today will begin with a video on the Artemis 1 mission, narrated by Mr. Heitzman. We will then look at a few constellations, Cygnus, Hercules, and Draco, followed by the planets Mars, Jupiter, and Saturn, which are all visible in the early October sky. We hope you enjoy the show.
NASA is now less than 1 year away from launching the first Artemis program mission to return us to the moon and eventually go on to Mars. So let's take a look at the Artemis 1 mission, which will be a 25-day flight to the moon and back with no crew. Coming out of the Vehicle Assembly Building at the Kennedy Space Center in Florida, you're looking at the most powerful rocket ever built. At the very top, the launch abort system covers the Orion spacecraft and the third stage of the rocket, and then you will be seeing the core stage and the two solid rocket boosters. We're targeting July, second week of July, for the launch of the mission, and the purpose is going to be to check out all of the onboard systems as well as the ground systems to make sure that everything is working as required and as designed and in concert for a successful flight. Coming up on pad 39B at the Kennedy Space Center, you get a closer look at the rocket itself. Launch abort system at the top. The Orion spacecraft tucked underneath it. The third stage also tucked under some protective panels. And then there's the core stage with 4 main engines and the 2 solid rocket boosters. As we get into the count, we approach 30 seconds. The engines are starting to get up to pressure and ready to go. And then at 15 seconds prior to liftoff, the sound suppression system will kick in. At T-minus 8 seconds, the main engines fire. And at T0, the solid rocket boosters fire, and we have liftoff of the entire Artemis 1 mission to the moon. Moving now to the 2-minute mark in the flight, you're going to see the solid rocket boosters separate as they finish their particular portion of the flight. And at roughly 3 minutes and 40 seconds into the flight, the service module protective panels will be jettisoned along with the launch abort system, which is no longer needed. At about 8 minutes and 14 seconds into the flight, the main stage will cut off its engines and the first stage will separate, leaving the upper stage and the Orion spacecraft in Earth orbit. At 16 minutes, the solar panels will be deployed to start picking up the electrical power. And then at roughly 54 minutes into the flight, we'll have our first burn to adjust the orbit, raise the perigee to keep us in orbit around Earth for 1 revolution. And 1 hour and 25 minutes after liftoff, the upper stage performs what we call the translunar injection burn, which takes us out of Earth orbit and onto the path to the moon. At 1 hour and 53 minutes, the upper stage separates from the Orion spacecraft, and it will supply us with some commercially usable nanosatellite deploys before the third stage comes back and burns up in the Earth's atmosphere. For the next 3 to 4 days, we will be in what is called the outbound coasting phase of the flight. And then as we get closer to the moon, we will be doing what is called an outbound powered flyby. And that'll be about 4 days and 7 hours. Making use of the microgravity assist that the lunar surface provides us with. We'll be orbiting the moon from day 4 to day 19, checking out all of our onboard systems and making sure that our orbit pre-flight determinations are as accurate as we predicted. Then on day 20, we do what is called the return powered flyby using the engine that's located in the service module on the back of the Orion spacecraft. Then from day 21 to day 25, we have the inbound coasting phase, getting us ready for our return to Earth. On day 25, the service module will separate from the command module of the Orion spacecraft. Command module will do its 180-degree turn to expose the heat shield for re-entry into the Earth's very hot atmosphere of 5,000 degrees. Then 11 hours into day 25, you have re-entry. You'll see the parachute panels deploy, followed by the drogue chutes to slow the spacecraft down, and then the main chutes will deploy to bring Orion to a nice soft landing in the Pacific Ocean just southwest of San Diego, California. Once splashdown is complete, a Navy vessel will move in to recover the Orion command module, as well as the parachutes, bring them on board the naval vessel, and bring them back to the naval station in San Diego, from which they will be airlifted to the Kennedy Space Center. And there you have it, the Artemis I mission virtual.
Our next segment is over 3 constellations: Cygnus, Hercules, and Draco. To begin, let's discuss how we can locate these stars in our night sky. Is everyone familiar with the Big Dipper? It's a good starting point for finding Draco. To begin, look to the north, not too high over the horizon. Once you find the Big Dipper, you can use the 2 pointer stars at the end of its bowl to point you up to the North Star Polaris. Polaris is the end of the Little Dipper's handle, and you can follow that handle all the way to the bowl. Can you see how the Big and Little Dippers pour into each other? If you can find them in the night sky, you're well on your way to finding Draco. Draco is slithering between them. He's a serpent dragon. He weaves between them and then up into the sky. If you follow Draco's body all the way to his head, he's looking straight at the foot of Hercules. Hercules is in a kneeling position. I will explain why later, but for now, see that these stars show his bent leg. Back here is his other leg, and the square in between is his body. He's holding up a club in one hand, and the other arm is up and back. Now let's go high into the sky. If you were outside, you'd need to be looking almost directly up. This is the Northern Cross. It's a plus sign that's pretty easy to see in the night sky because of how bright the stars are. This star here is especially bright, and that's the one to look for when you go outside. Its name is Deneb, an Arabic word meaning tail. This is the tail of Cygnus the swan. The arms of the cross stretch out to make his wings, and the last star points outward to form his neck and head. Now that we have found our constellations, let's go through the stories associated with each. I'll go through them in reverse order. Cygnus was not always a swan. He originally had human form. He is the son of Poseidon, the Greek god of the sea. He was friends with Phaeton, the mortal son of the sun god Helios. The Greeks believed the sun moved across the sky because Helios pulled it with his chariot. One day, his son and Cygnus were racing across the sky in their own chariots. They were very competitive, and they pushed each other faster and faster. They became reckless and got too close to the sun. Their chariots burned up, and they fell to earth. Cygnus, being immortal, was able to survive. He was merely knocked unconscious. But when he recovered, he went looking for Phaeton, because he was very worried. You have to remember, Phaeton was mortal. The fall might have killed him. Cygnus found Phaeton's body trapped at the bottom of the Eridanus River. He knew his friend was dead, but he wanted to retrieve the body. The Greeks believed that your soul could only go to the afterlife if you received a proper burial. Unfortunately, the current was too strong for him to swim to the bottom, and so he went to the Greek god Zeus to request help. Zeus told Cygnus that he could turn him into a swan to allow him to reach the bottom of the river. But if Cygnus agreed, he would be trapped as a swan for the rest of his life, a life that would be only as long as a swan's natural lifespan. Even so, Cygnus agreed. With his new swan body, he was able to reach the bottom of the river and pull Phaeton's body out. He gave his friend a proper burial. When Zeus saw what Cygnus had done, he was so impressed that he placed the image of Cygnus the swan into the night sky. Now let us return to Hercules. Hercules was one of the most famous Greek heroes. He was the son of Zeus and renowned for his strength and courage. He accomplished many great feats. 12 of these feats are known as his 12 labors, given to him by the oracle at Delphi. These included killing a lion in the multi-headed Hydra, capturing a boar and a bull, herding the cattle of Geryon, and stealing golden apples. Of the 12 labors, we are interested in his 10th and 11th in particular because they relate to the constellation of him. Hercules' 10th labor was to capture the cattle of Geryon and herd them all the way back to Greece. This was a huge challenge because Geryon was a giant. Hercules knew he could not match the strength of Geryon, and so he used his bow from a distance to defeat Geryon without a fight. After successfully rounding up the cattle, he began his return to Greece. He did not make it far, however, before 2 of Geryon's sons appeared. They were giants, just like their father, and they blocked Hercules' path. They were intent on taking the cattle back and having revenge for their father. Hercules knew that he could not win on his own, so he knelt down on the spot and prayed to his father Zeus for help. Zeus granted Hercules his protection, shielding him from harm, and Hercules was victorious over Geryon's sons. It is because Hercules knelt down to pray for help that his constellation is in a kneeling position. Hercules' 11th labor relates to another constellation in the night sky, Draco. As I said, Draco was a dragon, and he guarded the golden apples Hercules was tasked with stealing. The tree was a gift to the goddess Hera on her wedding day, and she had Draco protect the golden apples. He would sit, curled around the tree, so that no one could approach it, and he protected it for many years, but eventually Hercules appeared, confronted the dragon, and defeated him. That is why one of Hercules' feet is on Draco's head in the constellations. To remember him, and as thanks for his faithful service, she put his body in the night sky, so that all might see him and admire him. That concludes the constellation portion of our show. We will now hear about the planets Mars, Jupiter, and Saturn from Zach.
So starting out, my name is Zach, and welcome to the Planetarium show, the Homecoming Planetarium show. We're going to start things out with the planet section. We're going to start off with Mars. Now, Mars is this lovely red dot on the screen above you, and NASA confirmed that there was water on Mars, and so the reason why you're seeing all this red is that water had oxidated and reacted with all the iron in the soil, turning it into rust. So you're actually just looking at a giant ball of rust out there in the sky. It used to have flowing water, but now it's all frozen underneath the surface. And so it's negative 195 to 70 degrees. On average, it's negative 80. So it doesn't really give a chance for that water to melt. The day is 24 hours and 39 minutes, pretty similar to ours. It once had a molten core and also had a magnetic field, but it's no longer active. And it does have an atmosphere, so it has winds and clouds. And then the next slide here, we're looking at a closer look at the Valles Marineris. It is enormous. It is a giant canyon located on Mars' surface. It's 60 miles wide, 6 miles deep. So this is a graphic of it comparing to the United States. And as you can see, there's a Grand Canyon, and we all know how massive the Grand Canyon is, how beautiful it is, but it does not even pale in comparison to how big the Valles Marineris is. And the next slide we're looking at, that is actually a mountain, or it's a dormant volcano. So Olympus Mons is also just enormous in comparison to our own Mount Everest in Mauna Kea. So Mount Everest is 5.5 miles, and then Olympus Mons is 17 miles high. So the reason it's so big is there are these tectonic plates. Everybody's heard about tectonic plates, and there are these hot spots where there's cracks in these tectonic plates, and this lava and magma will rise up to the surface, and then it'll react with the outside temperature, and then it'll cool and harden, and then that's how these volcanoes and mountains are formed. But with tectonic plates and having an active molten core, they move around a little bit. But since Mars is no longer moving, then that hot spot is sitting at the same spot, and it just keeps rising up and hardening, and so it's just getting bigger and bigger and bigger over time. Like, that's how the Hawaiian Islands were formed, is the hot spots in the tectonic plates, they kept shifting around, and so we have a chain of little molten lava islands. So the next slide here, we're looking at one of Mars's moons, that's Phobos. And then the next one is Deimos. We know it's Deimos because it looks like a dog bit out of it. Then we have the big boy, Jupiter, the king of the sky. The day is only about 10 hours long, so it's spinning very fast. And then the core inside Jupiter, the core's temperature is actually hotter than the surface of the sun. There's just so much mass just compressing into that surface, or into that core, that it is hotter than the surface of the sun. And it is still releasing heat from that formation. So all that fusion, that accretion, is just giving off tons and tons of energy. Next slide, this is a zoomed in photo of the Great Red Spot. It is a massive hurricane on the surface of Jupiter, and it can fit 3 Earths inside of it. So it is enormous. And these are Jupiter's moons. That's Io, Europa, Ganymede, and Callisto. We're going to talk about Io first. We know that Io is a little cool. It has a cool color, but it also has this really cool feature over on the left side there. And it's like this canyon, and it looks like it says on. So whenever you look up in the night sky and you see the words on, then that's how you know you're on Io. This one is Europa. It is an icy moon, and it's thought that there's water underneath the surface of it, and so there might be life on there, or in there, actually. This is Ganymede. Ganymede is the largest of the 4 moons. The next one is Callisto. Now, Callisto is my favorite. It looks like the giant disco ball in the night sky. It is the most cratered object in our solar system, and it's just really, really pretty. Now we have Saturn. So if you look at that picture, Saturn's just kind of squished, it looks like. And that's because Saturn is spinning so fast that all that mass is trying to escape out to the outside. So it's kind of expanding out, what's known as centrifugal force. So it's almost an 11-hour day. And these are the rings. So the rings are divided into 7 major groups. So the first layer is dirt, the second is ice, and then there are some gaseous rings. So those are all just dirt, ice, and gas. And it's really, really thin, the rings are. So they expand out, and that's what this graphic is of. It has a thickness of 700 feet to 10,000 feet, so very, very thin. And then these are the moons of Saturn, and the largest is being Titan. And Saturn has a lot of moons. There's over about 25 moons in Saturn's gravitational pull. Expanding. Yep. So that concludes my portion of the show. I hope you enjoyed.